Hey, thanks for having me do this Q&A show. Appreciate that. And thanks everybody for joining. We always enjoy getting to visit with our partners and discuss hot topics and things of importance. As we know, our industry is constantly changing. So today I wanted to discuss Wi-Fi in general. And because I've been getting a lot of questions about AC versus AX and ways to apply and why to use one technology over another, the importance of the spatial streams, because there's a lot of preconceived notions based on what we think we know because of what's been marketed to us. Versus how things technically work, just because it's easier to say one thing based on what our consumers think they know versus applying the reality of the technicalities of something. And I'm a technical sales guy. I'm a solutions guy. So I'm going to be reviewing all of this from a technical sales and solutions aspect. I'm not a product engineer. I'm not going to get into how to do things. I primarily talk about how things should be done and what the differences are between these technologies, use case applications, and benefits of using certain ones over others. And then if there's ever any questions about the how-tos in regards to how to configure, things of that nature, those are discussions to have with our engineer. All of our partners have access to pre-sales engineering through the partner program. I am the channel account manager for our central region. And then, of course, I've got two colleagues, Andy that covers the West, and then David that covers the East. And if you are not a partner, please get back with us, and we can discuss the partner qualifications and get you set up as a partner, because this is this kind of education is always available to you anytime you call me or send me an email wanting a particular review of anything. So that's what we're here for. So anyways, to get on topic here, I've got the email that I sent out. And so I'm just going to kind of follow, and this is going to be a very informal review. I'm an informal guy, solutions guy. I've been in front of your customers before, and you can always use me to help you close deals. You can always use me to help explain solutions. So I'm just going to kind of start at the top and work my way down. AC Snapshot. So basically what that means is I want to talk about AC general technology, because that's what's going to segue us into AX. A lot of y'all are already going to know. Some of this might be new. So AC is Mu-Mimo, generally speaking, across the board. And what Mu-Mimo is it's when we're dealing with multiple spatial streams, whether it's 2 spatial streams, 3 spatial streams, 4 spatial streams, Mu-Mimo simply means that you're communicating simultaneously only with one spatial stream. It has to wait for each spatial stream to send and receive its packets. And each spatial stream is essentially a one-way road, because the radio itself, your 2.4 gigahertz radio, has 1, 2, 3, 4, 5 spatial streams, and each one is a separate lane within your road. And that lane and or road is one way, where it goes one way and then the other way, one way and then the other way. And it doesn't go back and forth simultaneously on that spatial stream, because wireless is half duplex. So it sends and receives packets over its lane. So when we get into 2 or 3 spatial streams, those are multiple lanes on the same radio. And on 2.4 on AC, each lane is communicating individually with the client. And the significance of this is that clients typically support 2 spatial streams. Most clients are only 2 spatial streams. And that packet that is traveling over that spatial stream from that access point is reflecting, penetrating, bouncing around. And whether that client is connected on 1 spatial stream, 2 spatial streams, 3 spatial streams, the time that it takes for that packet to get to that client device might be different than the time it takes for that packet on the other spatial stream. That's the significance of multiple spatial streams, because it gives us multiple lanes within the same radio/road to send and receive information across. So the more spatial streams our client devices support in correlation with the access point, the theoretical better performance we can get. And each spatial stream can only handle so much speed, and a lot of that is related to the airtime, because BGN and AC all have different air times between the client device and the AP. So Mu-Mimo is each spatial stream can only send and receive, and they wait on each other, and they're 1-lane roads. So then we get into Mu-Mimo. Mu-Mimo is where each spatial stream can communicate simultaneously. So they can independently send and receive packets across multiple spatial streams on that same radio, so that they don't have to wait on each other. Now, granted, it's still half duplex, because each lane within that road, which is spatial streams, that traffic only goes one way and then the other, one way and then the other. However, if that client's connected to 2 spatial streams and it's Mu-Mimo, at least those 2 streams can independently communicate with the AP. Now, Mu-Mimo is specific only on AC when it's in relation to Wave 2. Wave 2 is a specific feature set that only applies to 5 gigahertz. So a traditional AC access point is Mu-Mimo. If somebody says it's a Mu-Mimo ACAP, it's because it's a Wave 2 AP. And that Mu-Mimo is only applying to 5 gigahertz on that Wave 2 AP, because that's a Wave 2 feature set. Same with beamforming. Beamforming on 5 gigahertz on Wave 2 APs. And again, this only applies to 5 gigahertz, because Wave 2 is a 5 gigahertz feature, does not apply to 2.4. On 5 gigahertz, you get beamforming, which is what I personally like to call static RF mitigation, because it's a static feature where it broadcasts hundreds of different beam shapes. And then when the client device connects to that beam, it's connecting to the beam that has the best quality available to that client. But as soon as the client starts moving around, it relies on fast roaming to go from signal to signal to signal. That's why when Wave 2 first came out, there was a lot of fast roaming problems, and everybody was blaming fast roaming on the access points or whatever. It's because in the beginning, fast roaming, even though it was a supported feature, it's a hard-coded negative dB on the product itself. So you have to be able to manipulate that fast roaming setting to fit the environment to maximize the performance. So in the beginning, you weren't able to customize that. It was relying on the hard-coded negative dB. So when Wave 2 came out with all that beamforming, a lot of them wouldn't properly let go and go to the next signal, so they had major signal quality issues. So that's why there was a lot of improvements over that time over the fast roaming feature sets, because that's where the birth of customizing fast roaming came from, so that you can manipulate the negative dB in your, for us, it's a nebula called smart steering, where you can actually change that fast roaming setting to go from signal to signal to signal, as well as from AP to AP. And again, that's specific to beamforming Wave 2 access points, with the exception of when we're going from AP to AP. That's a general thing. But it does rely on fast roaming to go from signal to signal on a Wave 2 AP with that beamforming. So the reason I brought all that up is because that does segue us into AX. But there are still a lot of good use case applications for AC, which I'll get into here later. But generally speaking, that's how AC works, is you've got 2.4 and 5. On 2.4, it's Mu-Mimo. On 5, it's Mu-Mimo, unless it's Wave 2. If it's Wave 2, then it's Mu-Mimo with static beamforming. So this actually takes me into smart antenna. Smart antenna is a proprietary technology that Zyxel owns. We own the intellectual property for this. We developed it. And by the way, we develop our own hardware. We do all the R&D. We create everything. We own it all. So smart antenna is a technology where there is a separate set of antennas that's inside that access point that scans the environment. And then what it does is it looks at the RF interference in the environment, and then it actively manipulates the shape of the signals that are being broadcasted by the both 2.4 and 5 gigahertz radios. So essentially, it's beamforming, but dynamic. So now you've got hundreds of beams that are being broadcasted in different shapes, being dynamically adjusted to fit the environment. And then we do have a competitor that has something similar. But what sets us apart is our smart antenna is a full feature set. We do not sell it on multiple levels. You do not get it in multiple grades like our competitor does and charges out the wazoo for it. And then the major difference in regards to the technical application is our smart antenna tracks the connected client device, and it keeps it on the signal that is the best for it in that environment. The smart antenna itself does that. And then it only relies on fast roaming to go from AP to AP. So when you're dealing with like Wave 2 with beamforming, going back to that, you're relying on fast roaming to go from beam to beam on those static beam shapes, which again is only on 5 gigahertz if it's Wave 2. Our smart antenna technology, it applies to both 2.4 and 5 gigahertz, and it actively changes the signal shapes to fit the environment, and it tracks the connected client device to keep them on the signal that's the best quality for it. So it's constantly scanning, constantly manipulating those shapes while maximizing performance of all the connected client devices. And it only relies on fast roaming to go from AP to AP whenever it hits that fast roaming setting inside your controller. Our competitor, they rely on fast roaming to go from signal to signal, just like with Wave 2, the way Wave 2 works. So if theirs is properly configured on the controller to maximize performance, there is a delay with that fast roaming having to do its job to move it from signal to signal. So I can confidently say that in every field test, every real life applicable field test, we have beat them, hands down. And all those tests were done whenever the technology came out, which was before my time. It was like six years ago, something like that. Not a long time before my time, but anyways, that's what makes us ideal for high density environments. Like we're in tons of churches, football stadiums, public recreational areas, malls, and any access point with smart antenna. That is the ideal AP to use with any application, first of all, because it makes your life easier, because it dynamically fits the environment, while also being ideal for high density environments because it actively mitigates the RF interference. And that feature is a feature for both AC and AX. It's model specific. When you're looking at the antenna on a particular model, it's either going to be ceiling mount, wall mount, transitional antenna, or smart antenna. So that all signifies what kind of antennas they have. So rolling over into AX, unless anybody's going to pipe in with any questions about any of that. Rolling over into AX, so it has Mu-Mimo on both 2.4 and 5 gigahertz natively. So that means on all the spatial streams, regardless of how many you got, they can simultaneously send and receive packets. So with the new AX technology, it's a faster connection because the airtime is less. The less airtime you have, the more requests that you can have on that AP from the concurrent number of client devices. That's why it's marketed. Well, one of the many reasons it's marketed as being able to have quote unquote more client devices, which that is still relative, and you'll have a better understanding as to why after we review all these things, because AX has shorter airtime. However, when you have AC client devices connected or BG or N devices connected, those all have different amounts of airtime utilization. So once you start mixing client devices on any given access point, you are at the mercy of the airtime of those client devices. So even if you have an AX on there side by side with an AC or BGN, that AX has to wait for that other one to finish. Because even with Mu-Mimo, that's Mu-Mimo multiple spatial streams connected to that client. However, that client has its own connection to that AP. And each individual client has its own connection to the AP. And like if it's a 3 spatial stream AP, well, if that client device supports 3 spatial streams, which by the way, most don't, then it's going to be connected on all 3. If it's only 2, it's going to be connected on 2 of the 3. But then you got all the other client devices that are connecting to the same ones that you're having to wait on. So again, when you mix it with BGN and AC, unless it's an AX explicit network, you're not going to be maximizing the airtime on that AP because of the dynamics of the differences between those. But because it is Mu-Mimo, it does provide performance gains with those other devices because now it can simultaneously communicate. And there are some requirements on the client side to be able to support some of this stuff, because some of them have reduced feature set NIC cards. So again, all of it still has to do with what the client supports, but generally speaking, that's how it works. You've got Mu-Mimo on both 2.4 and 5 gigahertz. So now I want to talk a little bit about co-channel interference, because the easiest way to talk about co-channel interference, excuse me, I got another call coming in apparently. I got to figure out how to end this without disconnecting us. I don't think I can. That's fine. Co-channel interference is like having people standing in a room playing catch with lots of other people. And so you're the access point playing catch with all the connected client devices. And so when you're all on the same channel, you've got all these people that are connected to your channel throwing balls at you. And with AC, there's no way of identifying which ball is your ball. Which ball are you supposed to catch? So you're just catching all the balls, and then you look at the ball. If it's your ball, you keep it. If it's not your ball, you drop it. So that's why co-channel interference can cause a lot of problems, because when there's a bunch of access points and client devices communicating on the same channel in the same environment, these access points are picking up all the packets on that channel and trying to process them. And if it's not for that AP, then it drops it. And that takes up airtime. So the more packets you have on that channel that aren't for that AP, the more co-channel interference you're going to have and the more reduced performance you're going to have on that access point. Well, this segues me into color coding, because color coding is an AX specific feature. So color coding is where the access point puts a particular code on the packet that it sends and receives from that client device. So think of it as color balls. So you're the red ball person, and you're throwing a red ball to all your clients. And then the AP next to you or down the hall or whatever that's on the same channel, they're a blue ball person. So they're throwing blue balls to all their client devices. So those balls that are all getting thrown back, you know, that AP, that's a red ball AP, is going to see the blue ball, and they're going to be like, no, that's not my ball. And then they're going to ignore it and only catch the red balls. So now they're not grabbing the packets that are not supposed to belong to them. So this is where the higher density environment marketing comes from, because you can use these, quote unquote, in a higher density environment, because this technology reduces the amount of co-channel interference due to the nature of color coding, because now it can simultaneously communicate with all the client devices, even with co-channel in the environment, much more efficiently. And these two pieces of technology, being on both 2.4 and 5 gigahertz, is what has allowed the increased performance to be facilitated on AX because of that reduced airtime. So because of that, it dramatically reduces issues that we have with AC and everybody previous, so that we can get that faster throughput speed over that AX connection. And now, granted, there's a bunch of environmental factors that play into this because of all the other connected client devices. So there's no guarantees on any of this. So that's a general major difference between Wi-Fi 5 and Wi-Fi 6. Because with Wi-Fi 6, with that AX connection, you do get faster throughput speed per spatial stream than you do with AC. However, having Mu-Mimo and color coding on an AX access point, a lot of people have said, Jake, I don't even have any AX client devices, and simply replacing my AC APs with the AX AP, things worked better. Well, yeah, because the communication is more efficient. We're generally speaking not even getting into controller settings or site-specific setups. That's just general comparisons. And it's because of the difference in the technology that those APs can facilitate in relation to its predecessor with AC. And so all of this plays into the spatial stream importance. Because, you know, the more spatial streams you have, here's the marketing side of things. The more spatial streams you have, the better the AP. That's not necessarily correct, just so y'all know. If you're a marketer and you look at things from a general overall perspective, yeah, I can see why you would say that. More spatial streams, the better. Okay, yeah, from general layman terms, fine. You can get away with saying that all day long. But when you look at real life client application perspective, most client devices are 2 spatial streams, sometimes 3, very rarely 4. And the more spatial streams that a client device connects across, the more efficient it is for that client device to communicate with the AP, which gives it more potential bandwidth. right? But you are limited to the cumulative bandwidth, including overhead, depending on the environment, and the back-end infrastructure of that network. There's a whole bunch of things, right? That's still there. However, this is where we get into the pipe, because if you're still doing old school 1 gig wireless connections, and I say old school for a reason, I'll get into that in a minute. If you're connecting that access point to a 1 gig connection back to a switch, you have a 1 gig pipe to share amongst all the connected client devices. So when you're doing AX deployments, there's really no huge benefit to more than 2 spatial streams on a 1 gig connection, with the exception of if there is a lot of 3 or 4 multi-spatial stream client devices in the environment. Because if you do have 3 or 4 multi-spatial stream client devices in the environment, yes, get 3 or 4 multi-spatial stream access points if you want to optimize the connection, take full advantage of all the spatial streams that those client devices can connect to, making sure that the access point can support them. Just keep in mind that that's great and all, because it does maximize the efficiency communication back to that AP, but you only have so much of a pipe to share amongst all the connected concurrent clients. So when you have 1 or 2 clients on a 1 gig connection, you're going to maximize your throughput speed to those clients, even with a 4x4 multi-gig, or I'm sorry, a 4 spatial stream up and down access point. And again, it depends on the client, because even on some of these business laptops, it'll support like 3 spatial streams up and 2 down, or vice versa. You got to really get into the spec details of the NIC card. You wouldn't believe how many NIC cards are different numbers up versus down. And they don't advertise it that way. Like if it's 3 up, 2 down, they'll say it's 3x3 or something. I don't know, but they're not clear. They're never clear about it. I just learned a lot about this when I was buying my own new laptop and these different things, getting into use case applications with another partner. And believe it or not, most devices don't maximize the usage of more than 2, but some do. So that kind of segues me into explaining multi-gig, which is an AX feature set that is over AC. Multi-gig is the ability to connect at 2.5 gig or 5 gig. So now we're kind of getting into different ways of defining technologies, because when different manufacturers are saying multi-gig, it can mean either 2.5 gig or 5 gig, or both. So you got to kind of get into the specs of the product, or even 10 gig. There's a variety. But basically what it means is, originally we've got 10, 100, 1 gig, 10 gig. And that negotiation speed is reliant on the connected client device. So when you connect a 10 gig client device into a 1 gig copper port, it's going to connect at 1 gig, right? And when you connect a 10 gig client device into a 10 gig copper port, it's going to connect at 10 gig. And same thing with SFP. If you've got an SFP plus switch, but you use an SFP transceiver on both ends of that fiber cable, that port's going to connect at 1 gig. If you use an SFP plus transceiver on both ends of that cable, and they both support SFP plus, it'll connect at 10 gig. So it's going to connect at whatever the proper configuration and combination of products are that is the fastest, the slowest device can support. It works the same way with multi-gig. So certain AX APs have 1 gig, have 2.5 gig, or have 5 gig copper ports. And if it's a 5 gig, it'll do all of them: 5 gig, 2.5 gig, and 1 gig. If it's a 2.5 gig, it does, all of them down from there, so on and so forth. So the significance of this is, let's say you got a high density environment where, well, it doesn't even have to be high density. You got an environment where you got more than 2 client devices on an access point, and you want to optimize the aggregate speed across all the client devices. In other words, well, maybe that wasn't the right term, but you want every client device to get maximum throughput speed. Well, that's going to have everything to do with what hardware you're using. Because if you're sticking with an old school 1 gig connection running off of a standard 1 gig edge switch going to that access point, whether it's a 2.5 gig, 5 gig, or 1 gig, again, you only have that 1 gig pipe to spread across all those client devices that are connecting. And with AX, you can get upwards to 400 meg, sometimes faster. I don't remember the specifics and the speeds. Sean's done webinars and the super technical stuff that I kind of get lost on. But anyways, once you get 2 or more client devices, you've gobbled up your entire pipe to that AP. So if you use a 2.5 gig multi-gig switch and you plug that into a 2.5 gig multi-gig access point, now you got a 2.5 gig pipe to share amongst all the client devices. So you get 10 client devices on there. You got a 2.5 gig pipe between the switch and the access point to share amongst all of them. Now, a lot of people are like, well, what benefit is that if you don't have a gig or faster internet connection? It's not about that. Because the client is only pulling 300 meg, 400 meg, whatever it's pulling. That's less than a gig, which is where your bottleneck is going to be, unless you've got a full 10 gig backbone to a local server or something. But my point is that it's less than a gig. So the idea is to get as many client devices on that access point, pulling max speed from that switch across to whatever direction it's going to on that switch. And most of my multi-gig switches have 10 gig uplinks on them so that you can plug them into a daisy chain. So if they're accessing local data or whatever, it's opening up throughput out to that WAN because you now have more throughput to share across all those connected client devices based on the topology of where they're going. So you now have 2.5 gig to share between all the clients, which means you can get max performance. Well, not max, because there's 5 gig also. You can get more performance versus a 1 gig connection shared amongst all those clients. And then it's the same concept with 5 gig multi-gig. You now have a 5 gig pipe between the switch and the access point. And if you do have internet connection speeds of like 500 meg or more, you'll start seeing some performance gains here too, because that's a 1 gig pipe that you have that's going to your 1 gig firewall that then has a 1 gig uplink to a multi-gig switch. So now, depending on how much traffic is going across that uplink out to the internet, you have whatever that internet pipe is available to all the client devices versus them being restricted to only having access to a 1 gig pipe across all of them when each can pull 300 plus meg. Because you get, 2 or more AP or clients on an AP, you're going to start to be bottlenecked because you can't get 3 clients to pull 300 plus meg on themselves simultaneously. It's not possible because you don't have the amount of bandwidth available to do it. So when you get into multi-gig, you do. And this also helps with bridging, by the way, because, wireless is half duplex, right? So the communication between the AP and the remote device is half duplex because it only sends and receives. that spatial stream cannot send and receive packets simultaneously. Again, Mu-Mimo is the multiple spatial streams sending packets simultaneously. So I have partners that are doing their bridge solutions over 2.5 multi-gig APs. And we have seen through wired devices plugged into a switch hanging off of a bridged 2.5 gig AP getting upwards to 900 plus meg, which is crazy because that's with overhead built in. That's fantastic. Which means that they are equally connecting all their spatial streams over 5 gigahertz across that bridge, Mu-Mimo across those multiple spatial streams, with a 2.5 gig pipe available to them. Because the more spatial streams that are connected, the more throughput speed aggregate for that client that's connected is going to have access to. So when you have a 2.5 gig pipe to pull from, you've got that half duplex bandwidth. So you take that 2.5 gig, divide it by 2, you've got 1.25. You've got your overhead. So we're sitting at 900 meg aggregate across all spatial streams using that bridge to wire devices on the other side, which is phenomenal. It's great. Now, 5 gig, multi-gig, I don't know what to expect with that. I wouldn't imagine it'd be any faster because you're bottlenecking down to a 1 gig connection to, like a workstation that's doing the testing, unless you're doing multi-gig, 2.5 gig to workstations, which is possible. I just haven't sat down and done that testing with any clients. But we do have a new switch series, which is our XMG 1930. And the XMG 1930 is a full multi-gig switch with PoE options that is excellent for edge switching, because I got a lot of partners now doing 2.5 gig multi-gig to their workstations, because you can get like a 2.5 gig multi-gig NIC card for a workstation for like $30 is what I'm being told. So doing multi-gig solutions is very affordable now. And that's a missed revenue opportunity that a lot of people are missing. But I'll get into that a little more here in a minute. But going to AX, if you guys are not looking at multi-gig when you're doing your site surveys, when you're asking your discovery questions, when you're discovering their pain points, when you're doing whatever in the world it is that you're doing to establish what kind of solution you're going to provide your customer, if you don't have multi-gig solutions in the back of your head, you're missing out on opportunities because your customer's not going to know how this works. And if you don't know how it works when it comes to a real-time application, email me. My email, everyone should have it, but I'll go ahead and give it to you. In fact, Rochelle, I don't know if she has a group chat for everybody to see, but it's Jacob, Jacob, Olson, Olson, excuse me, at Zyxel.com, Zyxel.com. You can share with me projects. In fact, I'm on site with a partner right now doing a church review, and that was just a major topic of what we just looked at, because the sanctuary's got so many stinking people in it that they got to maximize their bandwidth to the access points to share amongst all the clients. And so we're looking at 5 gig multi-gig to the WAX 650S off the XMG 1930 to share amongst all the clients. And that's going to really help with overall performance because it's a massive sanctuary. But then again, you still don't want more than 45, 50 concurrent clients. You can push it if you're doing good QoS on an SSID VLAN level. If you're blocking Netflix and different things. But the reason is because of packet loss. If you got a lot of activity on a lot of connected client devices, you can start overwhelming the AP because of the limitations of half duplex and cause packet loss. But because of the increased efficiency of AX, it's not as sensitive. And if you put multi-gig to it, it makes it even less sensitive because it is designed to handle those packet requests at those speeds. Because having Mu-Mimo and color coding, it allows it to. Without Mu-Mimo on 2.4 and 5 in color coding, we wouldn't be able to do multi-gig with AX. But having those two features with the performance gains of AX, we can do multi-gig. Now, there is a feature in the AP, in the Nebula AP controller, that restricts BG and N devices. So I know that in certain environments, they need that, but when we're doing stuff like public access, churches, whatnot, it's best to click that box and not let those guys connect. Because I know that there might be some complaints. It's all about setting expectations. If you want discussions with the customers to be true about this gain performance, all that's going to go out the window if you let BG or N devices connect. Because those stinking devices, they take up so much airtime that it's going to pull down the performance of everything. AC, it's yes, it is going to affect overall performance, but it's way more minimal than those other connections, because those are dramatically slower. But that's kind of my hot topic right there, is multi-gig. So AC applications, those are still popular, guys. We have a lot of environments that aren't heavy on AX yet. Oh, criminy, it looks like it's almost 2 o'clock already. I better speed this up. So hospitality, places where they're not so much interested in performance, however, they're just interested in coverage. I still encourage you to use our AC access points for that, because it's going to be a while before everything's standardized on AX to begin with, which is why I'm not getting into talking about 6E yet from a partner perspective, because AX itself is going to take time to universally be adapted. And that time frame is usually slowest amongst the hospitality environments, restaurants, hotels, gas stations. They don't care. So it's in your best interest to potentially use AC equipment, because you can typically get it still at better price points. And I still have a lot of selection on that. And you're welcome to reach out to me with questions on that. If you're ever doing AX deployments, do multi-gig. Have multi-gig in mind. If you're not, you're missing out on revenue opportunities, because there is so much performance gain with multi-gig, especially if this is properly addressed and the infrastructure is looked at. Because if there's a local server or a local NAS unit, anything local that these APs have access to, why in the world aren't we talking about multi-gig? Because it's a minimal investment, but yet a maximum, you'll get great response from it. And customers will like it, and it increases your overall value because they know nothing about it. So all of a sudden you've got some additional value and services to sell. And so you can leverage existing client environments to do that, because the multi-gig applications that I've directly trained on from partners that have brought me those opportunities, every one of them we've been able to maximize performance, satisfy the customer, and increase your revenue opportunities. All you got to do is look at existing customers and new customers. It's just like doing a normal network refresh, except now you've got multi-gig as a reason to do a network refresh. Sometimes you already have the APs in there. It's just the switches, or you don't. It has everything to do with the project itself. I'm here to help evaluate that and move that forward. So if you're not doing that, you're really missing out on revenue opportunities. So as you can see, there are some immediate performance gains on AX deployments over AC in certain environments where it makes sense, because AC still makes sense in a lot of applications. AX makes sense in other applications, even if all the client devices aren't AX. And then in other applications, multi-gig, multi-gig, multi-gig. Easy solution to dramatically increase performance. And Nebula is going to be your go-to cloud management platform. I cannot stress that enough. If you're not already using Nebula, my first question is always, why not? Well, the response is they haven't taken the time to learn it or look at it or whatever. It's whatever the reason is. But my point is that Nebula is amazing. It allows you to do zero-touch provision. And by the way, guys, I'm not a used car salesman. I'm an old Sonic Wall champion. I've worked with Sonic Wall, Fortinet, Ruckus, you name it, championing all their products through D&H, Ingram, Tech Data back in the day before it was bought by Synex. And this is the reason why I work for Zyxel now, is because I can't say something is the best just because I sell it. Because quite frankly, personally, I don't care what you buy. I'm not here to push product. I'm here to help with solutions so that whatever it is that you do, you're going to maximize your services back to your client so that you can get referrals, increasing your revenue opportunity. And that's what grows our business together. And that's what's important to me. That's really important to me because Zyxel as a brand, we are a business brand. We don't do national marketing. Our brand recognition isn't the greatest in the U.S. market, even though over in Europe and everywhere else, we're known like Kleenex. And that's because, for ISPs like Comcast and so on and so forth, we white label for them. So the end user doesn't know it's our equipment that's connected to their internet. Whereas over everywhere else they do. It's got our name all over everything. But my point is that due to those different challenges and different things, we really go above and beyond to provide these support resources to our partners to help them grow with any networking opportunity. And a lot of times it's something that's hard to adjust to because I know these other brands don't do it. And I know it's hard to trust that that's what we mean when we say it, because coming from Sonic Wall and Dell and other brands, I know they say it, but then they don't follow through with it because they usually don't know. They don't know what you're doing. We do. We know what you're doing. We know what you need to do, and we're here to help you with that. If we're taken advantage of, you could treat me like an employee. But moving that forward, Nebula is where you want to put everything because that's where you can do your granular, your fast roaming settings, your everything. You can see your Wi-Fi health report where you can see the quality of the connection of all the concurrent client devices, and it's free. It's a free cloud controller that you can put an unlimited number of access points in without the need for licensing. There's no reason to use Ubiquity.
Sorry, Jacob, to interrupt. We only have 8 minutes left for questions.
Okay. Yeah, I saw that, so I'm going to wrap up real quick. As a Zyxel partner, there's no reason to use any other brand for wireless. We displace price point wise, lower price point prosumer-focused brands, all the way through the higher, more expensive brands having free lifetime warranties, free tech support, and free cloud management. So if you ever have a reason that you're using someone else and you're not sure how we compare, please reach out. Rochelle, I'm going to go ahead and open up for questions, and I'm okay with going over if everyone else is okay with going over. But let's go ahead and start with our questions.
Yeah. First question, does it matter how high in the air an access point is installed?
Yes and no. So keep in mind, an access point, when it's installed on a ceiling, it broadcasts straight down in a cone shape. So the higher it is in the air, the larger the footprint is going to be once it gets to the ground. So when we're looking at the way we do our installs, if we only want 45 client devices and it's really high density, we got to take into consideration that if it's like a church, it's going to be way up in the air. So we're going to have a lot of overlap to hit our proper client device. If it's lower to the ground and it's a lower density where we can keep more power to the antenna, creating more of a blanket coverage because there's fewer people, well, then those APs can be spread apart even further with minimal overlap, and we're still going to have the same quality coverage. So yes, it does. The higher in the air it is, the more blanket coverage once it gets to the ground it's going to have, which is going to affect your install because of the environment. But when it's 8 to 10 feet off the ground, it's going to be a traditional coverage, which is then the way most people do it. And a lot of people don't do proper site surveys, and they just throw them up based however they want and don't ever have problems. But when you get into the nitty gritty, yes, it can. It just all depends on the environment.
Okay, next question. Thank you for that answer. Do all these types of access points broadcast the same distance?
Kinda, yes. So like when you look at our competitors, some of them have LR, like long range. Those LRs are basically full power APs, which all of our APs are. And when I get the question, how far do your access points broadcast? All business grade APs broadcast virtually the same distance, which is roughly about 150 feet from the center of that access point. Now that's in a clean and outdoor environment. You don't necessarily rely on the signal quality that far out. 120 feet is kind of the max distance, but again, it has everything to do with the environment. Is the blanket coverage consistent amongst all APs? Yeah. When they're on max power, yeah. And do we look at it from a distance perspective? Not really, because it's pretty universal. When I get that question, it's usually because people are used to using a prosumer product that has lower power to the antenna, and then they sell another model that is long range. But when you're dealing with a full business brand like us and our business, using air quote, competitors, it's all the same.
Okay, on to the next. How far do the APs broadcast?
I touched on that. They broadcast about 150 feet from the center of the AP max. But again, I don't recommend using that distance. It'd be about 120 feet. But again, you can manipulate that by the power to the antenna. So when we do in Nebula, there's preset density features. There's only 3 of them. And it's based on the number of APs, which personally I've had discussions with Marcus about that. I don't like the way it's set up because it can create a confusion. But my point is that the higher the AP count that you set it to, the lower power it puts to the APs. But it has everything to do with the environmental conditions. So when you minimize the power to the access point, it shrinks the footprint. And there's a general controller setting, which is that presetting where you get to choose one of those 3 that affects all the APs. But you can also go in to the access point itself and change it per AP if you wanted to, which is common with like a church environment, because in the sanctuary, you want them on minimal power, but in the hallways and whatnot, you can have them on maximum power. So you can go in and change it however you want, but on max power, you're looking at like 120 to 150 feet.
Great. All right. We have a question here. Isn't the useful distance more likely to be limited by the client than the access point? You want me to repeat that? Okay, go for it.
No, I get it. So it's a mix. It really is a mix, because the client device itself, like this is a common issue with like cell phones. Cell phones have, depending on the cell phone, some of them have really weak wireless cards. So the AP itself can be broadcasting quite a distance with decent signal strength, and the cell phone or other wireless device can see it, but it can't connect. And the reason it can't connect is because the wireless card isn't strong enough to be able to carry that signal back to the AP. That's one example. Another example is if signal strength is not a reflection of signal quality at all. So if you have an AP pushing too much power, it's going to get dirtied up towards the edge. You could still have a strong signal, but every request that's sent to that AP could drop. So you can't authenticate. It's just going to sit there and whine and try to connect, but it can never connect. Well, that's because that signal's so stinking dirty that it can't connect back to it. So it all depends on that environment with that comment, because I've seen people blame client devices when trying to defend the wireless setup, when it was technically the wireless setup because they had their APs overpowered, causing their own RF interference, creating a ton of overlap where they didn't need to, not properly setting their fast roaming settings. Because I've seen clients trying to connect to the wrong access point because the negative dB in the NIC card, if that client device supports fast roaming, it was meeting the requirements of the fast roaming settings on the controller, but it wouldn't push it to the right AP because the fast roaming settings on the controller were not optimized in the environment. So it was trying to connect to the wrong AP. So it can be a variety of things, but the general answer is yes, that could very well be the client device in certain cases. But when we think it's the client device initially, it could be something else, but the client device very well could also be it. And if somebody's trying to connect with a particular client device and they're having that problem and they feel as if they should be able to connect within that environment where they're standing, and that's part of the scope of your job, then you've got something wrong, whether it's the configuration or the install. Because if they can see it and they can't connect, we can't tell them it's because of their client device if they're standing where they should or want to connect. Because depending on that install and those settings, it is possible to make it happen.
Awesome answer. All right, the last question. What does transitional antenna mean?
Great question. I love that, because when we're dealing with signal propagation, there's ceiling mount and wall mount. Those are the only two kinds. The AP will broadcast straight down from the ceiling like sonar, right? You're dropping a pebble in a lake. You're holding it up above the water. You drop it, it hits the water. It does that ripple effect thing. The harder you throw the pebble at the lake, the more ripple effect you're going to get. And how hard you throw it is your antenna power. So the more antenna power you're pushing, the harder you're throwing that pebble, right? And then the higher the AP is in the air, it gains momentum combined with the power you're pushing to it. So the higher the AP is in correlation to the power, it's also going to affect the distance of that ripple effect. Same concept with wall mount, except with wall mount, you imagine that AP being in that, right where that pebble hits the water, that's where the AP itself is mounted. So, and the power you push to that antenna is how far out it's pushing that ripple from the center. So if you were to put a ceiling mount AP on the wall, then you're pushing that signal out as a cone from the wall out. And then if you've got another AP in that environment that's on the ceiling, broadcasting straight down properly as a ceiling mount AP, you're going to have signal collision, because you've got signal being broadcasted from an improperly installed AP on the wall that's going vertically, when you got another AP that's broadcasting straight down horizontally. So what a transitional antenna means, that's a feature on an AP that has both ways to broadcast. So there's a switch on it, or in the controller, you can change it because there's two sets of antennas. So one set of antenna is designed to broadcast straight down in a cone pattern from a ceiling mount application. The other one is to broadcast as a circle pattern, 365 degrees all the way around that access point, so that that signal is being propagated horizontally wall mounted or horizontally ceiling mounted. And then that kind of rolls kind of into smart antenna, because smart antenna is also a separate antenna. And I have smart antenna wall mount APs and smart antenna ceiling mount APs. And they both broadcast their signal horizontally, manipulating the shape of the signal that's being broadcasted. But a wall mount AP is mounted vertically, like a wall plate. This is done a lot in hospitality. It's a wall plate, and then it broadcasts 365 degrees around it. Whereas an AP like our 610D or 510D, those are more ceiling mount form factor, but they have transitional antenna. So if you want to put an AP on the wall, which this is very common, putting them on walls like 8 foot up in the air whenever there's really high ceilings in places and they don't want to get all the way up there, or they put them on poles, which is fine too. You throw that 510D or 610D in wall mount mode, you throw it on the wall, and now it's propagating horizontally the same way as if it was in ceiling mount mode up on the ceiling. So it's very common to use that 630S in all ceiling mount applications, paired up with the 610D for the wall mount applications. And the reason is that's a 2.5 gig multi-gig AP, so that you can scale into 2.5 gig opportunities if you wanted to. And that 630S is the most budget-friendly smart antenna ceiling mount AP. And then you go up from there to the 640S, which is 6E, and then the 650S, which is, you know, another Wi-Fi 6.1, but it's 5 gig multi-gig with Bluetooth. So I have a battle card with all these access points on them that give a detailed difference between the different ones. So if you ever want that matrix, email me and I'll be happy to give it to you. But in a nutshell, that's what transitional antenna means. It gives you the option to switch between ceiling mount and wall mount modes. You're always going to see ceiling, wall, transitional, or smart. So when you see smart, just be aware that doesn't necessarily mean it can be used on a wall or ceiling, even though it could. But if it's ceiling, I recommend keeping it on a ceiling. It will work on a wall, but you're going to create some signal collision. I would recommend using the wall plate instead. But in a nutshell, that's what the difference is between those. And again, bring me opportunities, bring me any additional questions, email me. I'm here to help everybody grow their business with any and all wireless opportunities, all the way down to network security, which we'll talk about in a different call. I'm a security and Wi-Fi guy. That's what we're here for. Rochelle, you got anything else for me?
No, I think that would be it. It was an excellent presentation, Jacob. Congratulations. And it's well attended. And all I can say is thank you, everybody. And if you have anything else to add, Jacob, go ahead.
Okay, guys, this has been recorded and Rochelle's going to post this. She's going to mention here in a moment, Rochelle, if you don't mind mentioning where it's getting posted. Just so y'all know, we're going to be doing more of these. Please invite your friends, invite your engineers, invite whoever, because, you know, the more people, the merrier. And then you're also always welcome to email me subject topics that you may want to talk about in the future. They're always going to be podcast style. And please put any questions you want in there. The more interaction, the better. We did have a good turnout this one, and I would like to continue to grow it. So if I bored anybody or anybody has any feedback, please give it to me too.
Right.
Thanks for setting this up, Rochelle.
No problem. It's my pleasure. And you'll see the recording on our website on the support section, and we will send you the recording after this webinar. That's it.
And it's going to go to all the registered people, correct?
That's correct.
Okay.
All right.
And anyone that's not registered, you're welcome to share it. So you got any employees or anything that want to listen to it, feel free to share it. But again, I'm always willing to hop on a call and do technical training, even with Marcus. Marcus goes through all the technical stuff. So guys, I could go on and on and on, but we're at a stopping point. Again, thank you for your time and hit us up with anything you need.
All right. Thank you, everybody. Have a great weekend.
Thanks, Rochelle.
All righty.
All right. Bye-bye.
Bye.